Hello all, welcome to MRU E-Learning powered by Mallareddy University. I am Dr. Puranam Revant Kumar, Assistant Professor, Department of Artificial Intelligence and Machine Learning, Mallareddy University. Today I am going to give lecture on Introduction to Deep Learning. Before we starting, what is deep learning? Let us try to understand exactly the core concepts of artificial intelligence, machine learning and the deep learning. Before diving into the PPT, let me make sure clear that what exactly these three represents. Nowadays, these artificial intelligence, machine learning and deep learning are the booming topics in the field of computer science. Let us distinguish between these three. What exactly they are talking about, what they represent and what kind of role they are playing in our lives. So if we see today, artificial intelligence versus machine learning versus deep learning. What exactly these three are? For suppose, let us take, this is an AI. This is an AI. So, artificial intelligence. What exactly a artificial intelligence is? Let me make sure very clear with my basic definitions, like it will be very crystal clear and crispy so that everyone, the layman, will understand what is AI. So, what is AI? AI means it enables a machine to think. What it do? It enables a machine to think. It enables a machine to think. What exactly it says? For suppose there is a Google Assistant or Alexa. What we do? We will click on a long button so that the equalizer will appear on it. So whenever the equalizer is appearing, the meaning is we are enabling a machine to think and it is waiting for our waves, like whatever we are talking about. AI is nothing but it enables a machine to think. For suppose if I ask, who is the Prime Minister of India? So immediately the device will tell that the Prime Minister of India is Narendra Modi. How this is happening? So we are enabling a machine to think. After it think, what exactly happening? Let us see now. So this is AI. Now what is machine learning? Machine learning is a subset of AI. This is the machine learning. Machine learning is the subset of AI. What exactly the machine learning stands for? Machine learning is nothing but it is a statistical tool. It is a statistical tool which analyze and explore the data. I hope everyone has understand the difference between AI and ML now. So what exactly AI is doing? It enables a machine to think. Whatever the Google Assistant is there or Alexa is there, if we are telling hello, so the machine will listen first who is talking about what. So if I say who is Prime Minister of India to Alexa or to Google Assistant, immediately it will explore the data and it will say that the Prime Minister of India is Narendra Modi. So how it is doing? See, with the help of machine learning, it is a statistical tool which analyze and explore the data. Whatever the data is there with the machine learning, in the system it was already there. That will analyze and it is going to explore now. So this is what the machine learning part is doing. Now, where exactly the deep learning fits in this? So the deep learning is a subset of machine learning. So this is nothing but the deep learning. So what is deep learning now? Deep learning is nothing but which exactly mimics like human brain. Mimic like a human brain. What exactly we think? If we dream, the deep learning will dream. If we get angry, the deep learning will get angry. Whatever the actions we are doing nowadays, how we are able to see the millions of colors with our eyes, how the neural networks are processing and all, everything A to Z, how a human brain is mimicking the same way the deep learning will also mimic. So now, where the scientists and researchers thought, can we make a machine to think? So from there, the concept of this AI, ML and DL has come into the picture. All together we call it as artificial intelligence. The one artificial intelligence means it enables all three. It enables a machine to think. Once it enables a machine to think, next the machine learning will explore the data. Once the machine learning is started exploring the data, the deep learning will do with the help of images and all. So this deep learning deals with images. So this machine learning deals with the data sets. So I hope now it is very clear. The data sets and the images will play a crucial role in our day-to-day life, that whatever the data set we are taking, like let it be diabetes or heart disease or any other cancer-related data sets or COVID data set or any other academic data set and all, it's a statistical tool which analyze and explore very, very fast. And related to the images and all, how the pixels are performing and how to do the feature extraction, how to analyze the features in an image, etc. will deal with the deep learning. See, exactly the deep learning, how a human is seeing about the faces of other people and how he is distinguished between the human and an animal or a bird or a flight or a ship or a fish, etc. So, all the features of each and everything has been recorded in our brain previously. How a cat looks, how a dog looks, everything we know based on the features like pony ears, ponytail and the small face, and between the dog and the cat the height will be varies and all. These all features has been insisted by our parents when we are in childhood. So likewise, how your brain is mimicking, the same way the deep learning will also do. So this deep learning will deals with the images and all. So it will do classification between the images, whether it is a car or not, whether the patient have any tumors or not, whether this is a sheep or not. So these all the distinguishes between the things will be taken care by the deep learning. I hope so. People have understood what is AI, what is ML and what is DL. Let us dive into the deep learning. What exactly deep learning? From where it has been derived? What the scientists and researchers thought to get this deep learning into the environment? So we can see one by one, step by step now. So deep learning is a technique which basically mimics the human brain. As I've said in the previous slide, the deep learning is a technique which mimics basically like with the human brain. So the scientists and researchers thought, can we make a machine to learn the same way as the human is doing? So from where the concept of deep learning has been come. It's a very interesting. It led to the invention called neural networks. As you see here, it's a very big, massive breakthrough here. It leads to the concept called neural networks. How the neurons are playing a crucial role in our brain. The same way the deep learning will also deals with the neurons in the algorithm. So, how the neural network architecture is there inside our brain, we will see in the upcoming slides and all. So, the first simplest type of neural network is called perceptron. So, the scientists and researchers thought, can we make a machine to think, from where it derived a concept called perceptron. So, they have derived a concept called perceptron, input and the output. So what happened, exactly the point here is, the perceptron have the lot of problems in this. They are unable to apply for the real-time examples and all, due to the architecture design of the perceptron and all. So later on what happened, in 1980, the scientist called Geoffrey Hinton, he came up with the concept called backpropagation. Now what exactly the backpropagation is? Backpropagation means which reduce the error. The perceptron is unable to reduce the errors whatever the algorithm is showing the output. For suppose, if I am giving a cat and a dog to an algorithm, instead of cat, if I need a cat, actually output I need is a cat, but the algorithm is showing as a dog. So there is an error. See, if I am telling I need an output as a cat, so this is, let us take it as 1. But it is showing as a dog. The output is 0 because the error is more. High error is there now. How to reduce this high error now? This high error will be reduced with the help of backpropagation. So from where in 1980, the Geoffrey Hinton has come up with the concept called backpropagation. So the artificial neural network, the convolutional neural network, the artificial neural network, the convolutional neural network, and the recurrent neural network have become efficient that many companies are using it for developing a lot of applications now. So this is where the concept of deep learning has started with the help of the neural networks. Now let us dive into the topic, how exactly the neural networks looks like. So let us see now how exactly the neural networks look like. If you see, let me explain with the practical example of our human. So let me say, this F1, F2, F3 are the features. Now let me make sure clear that features are what? What are the features? For suppose, let me take a cat. Cat, one feature is it is in a small size. Second point is it has a pony ear, pointy ears. And it has the overall shape of the cat is very small. So, and the eyes are like blue, little bit of like blue eyes. So, these are the features of the cat to identify. So, now what happens, see, whenever we see an animal, whenever see an object, whenever see anything and all, we will identify the features for that. First of all, we will identify the features to it. So, based on the features only, we will distinguish what kind of category it belongs to. Whether it is a computer, whether it is a laptop, whether it is a mobile phone or an iPad or etc. etc. Based on what we are doing, based on its features, how it looks and all, we are doing that. So where these all are going? See, whenever I see an objective, those are input to my eyes. Those all are like input to my eyes. Please try to understand. It's a very clear and great concept. So if you understand how the neurons are working in our brain, the whole deep learning concept will be very, very clear and it's very interesting now. The F1, F2, F3 are the features. These features are nothing but those are I am seeing to my eyes. So these are the inputs to my eyes. The whatever the objects I am seeing, those all are inputs to my eyes. From input, it is going to my brain. It is going to my brain. Those neurons I am unable to see what is there exactly in my brain. I am unable to see. Those are nothing but hidden layers in my brain. These all are neurons. Whatever there in our brain, those all are neurons. So as we are unable to see it, we are representing it as a hidden layer over here. So these F1, F2, F3 are the features which I have seen. So those are passing through my eyes to the hidden layer. In hidden layer in our brain, there is a lot of processes happening. Lot of processes are happening. Those processes we will check in the next slide. So those are hidden layers. After completing the process and all, our mouth is nothing but our output. By seeing with the eyes, processing inside the brain, telling with the mouth is nothing but the human nature. Likewise, algorithm is also doing the same thing. F1, F2, F3 are the features and hidden layer is in between and later on the output, whether it is a cat or a dog, it is same. So this is how the deep learning concept is started and it is keep on going. I hope the concept is very clear. What are the inputs are there? Whatever we see with our eyes, those are the input to the algorithm. And the hidden layer is nothing but the neurons inside our brain. How it is doing process and all, that process we'll see in the next slide. And the output layer is nothing but your mouth. How you are telling the sensory organs, whatever is there to speak out. Though that is nothing but your output layer. Whether it is a cat or dog, you are say. This is how the human nature is keep on doing. Likewise, the algorithm is learning. So this resembles the artificial neural network. Now, there is no backpropagation concept here that we will see in the next slide. Okay. So, if it is a multi-classification, more than one node will be specified. Here another nodes will be there. As it is a single node binary classification, whether it is there or not there, only one node we are specifying at the output side. This is the output. So only one node we are specifying. So this is the overall concept of neural network, artificial neural network concept. Now, let me go more clear way and deeper way into the topic. So if we see how a neural network works, it's a very good concept now. How exactly the brain, the neurons are working inside our brain, the same way the algorithm is also acting the same. A perceptron takes multi-binary inputs. So it can take a multi-binary inputs here. And those applied weights to those inputs. I'll tell you what are the weights exactly with a practical example and all. Input, some of them and passes through a activation function to produce a binary output. Primary purpose of this perceptron is to make binary decisions, often used to binary classification. So what exactly it is talking about, let me tell. Now, see, let us go to let us go here and I'll explain what exactly the neuron is happening. See, let us think that this is the neuron. This is the neuron. What is happening inside our brain in the neuron? So whenever we are giving an input, there are two steps are happening inside the neuron. In every human being it will happen. Every human being it is happen. So step one, and this is the step 2. And this is the step 2. So in step 1, what is happening means input is multiplying with the weights. What is step 1? Input is multiplied with the weights. I'll tell exactly what is input and what is weights are multiplying. And step 2 is nothing but activation function. The whole concept of deep learning neural network revolves around this concept only. In a neuron, 2 steps are happening. Step 1, input is multiplied with the weights, and step 2 is activation function. Now let us go with the practical example so that the concept will be very clear. There are 2 hands of mine. On one hand, a mosquito came here. A mosquito has come here. And mosquito is bite. Mosquito is keep on biting. Do anything happen to my second hand? Nothing. Because the neurons here are cool. There is no pressure for me in this hand. But in the first hand, wherever the mosquito is keep on biting, the pressure will be more. The pressure will be keep on more. So my inputs are nothing but the mosquito which I am seeing. Input is nothing but the mosquito which I am seeing. So the inputs are multiplying with the weights. Weights means what? Pressure over there. So with how long it is keep on sucking my blood over here, the weights will be keep on increasing in my brain. It will create a pressure in my brain. It will create a more pressure in my brain. What I do? I'll stimulate. I'll hit that mosquito with my another hand. How we are coming to know that to hit with the another hand? That time your body is activated. Till that time your body is at rest. Until the mosquito is sucking your blood, your body is at rest. Whenever the pressure is more inside the brain, when the input, as you are seeing the mosquito, and the input and the weights over there, where exactly the mosquito is biting, the pressure is keep on more. When the pressure is more, the brain will tell you to stimulate it or kill it. So that time your body is activated and you are killing it. So these 2 things are happening inside your brain, inside the neuron. Each and every neuron is having these 2 steps. So this is what happening. So I hope that now the concept is clear how the brain is working every day. For suppose one person is calling, continuously is calling. You will get irritated and you will ask him like, why you are calling me? Continuously. So the input, the ears, whatever the ears are there, it is listening your name continuously. And if he is repeating continuously, the weights keep on updating. The weights are keep on, and you are getting irritation, and then your body is activated. I am coming or I am not coming. You will tell in the reply. So whenever the activation function is activated in your brain, you are responding to it. It's everywhere in the world. Whatever it is happening with you, you will have these 2 steps in your brain. One is the input, whatever you see, it is multiplied with the weights of that pressure or the happiness, whatever it is. It will multiply with that. And later on the activation function, you will say thank you. You will say I'm not happy. You will say I'm not good. Based on the inputs and the weights, the activation function will activate and you will give the output. So this is what the overall concept of neural network. Which is happening inside your brain exactly. The same way the deep learning is also doing the same thing. There are inputs, there are weights, a hidden layer that we are unable to see. Inside this hidden layer, there are 2 processes. Step 1 and step 2. From there, the activation function will give the proper output. Whenever the activation function is activated, then it will say whether it is there or not there, 0 or 1. So this is how the overall process of a neural network is working. Let us see the theory part now. Features x1, x2, x3 for my input layer. So these are the input layer. I want to determine the binary classification. So only one output is needed, whether it is there or not there. Simple. Now, let us consider what kind of process does hidden layer do and what is the importance of W1, W2, 3 weights. Now let us see the importance of this. As soon as the input is given to my eyes or to the algorithm, it will be multiplied with the respective weights. Already the weights are assigned to that particular objective or particular thing or particular data set or image. Everywhere the weights are assigned. It will multiply with the weights for that algorithm. Where intern inputs hidden layer, it will go to the hidden layer. The activation function will trigger now. This is the step 2. The activation function will trigger. Let us see the step-by-step process now. Step 1, what happened? The summation of the weights and the inputs. Summation of 1 to n. All weights. summation of weights with the inputs, all the inputs with the weights will be multiplied, Wi into xi, where you can see the output as y. Y is nothing but my actual output. Actual output. And y hat is my predicted output. What I am thinking, whether I got or not. If I am not getting, then how to do back propagation. That also we will see with one example. So y, W1x1 plus W2x2 plus W3x3. So y, W1x1, W2x2, W3x3, if you go to previous slide, input is multiplied with this. W1 with x1, W2 with x2, W3 with x3. So these are multiplying. Now the y is multiplied. The step 1 I said, inputs will multiply with the weights. Now the step 2 is activation function. That's it, very simple. Now in the brain, the step 1 is over. In algorithm also the same way, the step 1 is over. Before activation function, the bias will be added to summation follows. So W1x1 plus W2x2 plus W3x3 plus bias. So now the step 2 is nothing but activation function. Act of y. These activation functions can be more, n number, sigmoid, ReLU, leaky ReLU, tan H. There are n number of activation functions are there. Each activation function will have a different kind of specifications and the working condition of it. If it is a classification problem, we'll go with 0 or 1. Whether it is there or not, they're simple. Will be obtained. This example is a forward propagation. See, the concept is very clear now. This example is the forward propagation. Then what happens if there is an error? See, we are keep on going as a forward only. If I need y, I need an actual output. But if I keep on going, I got a y hat. Predicted output is wrong. Whatever I have predicted was wrong. So what I have to do now? Now the concept of backpropagation has been introduced. With the help of this backpropagation, we can reduce the error. Whatever we have seen the error, that we can reduce now. How to reduce this error? In human nature, how we are applying in the academics and all, what is the perfect example in the academics for this error reduction and all, we will see now. So activation function. Activation function is a mathematical gate in between input fed to the current neuron. See here, very good they have explained here. See, the activation function is a mathematical gate in between the input fed to the current neuron. So whatever input has fed from our eyes, it is keep on moving and it is spreading and it is having the gate. Gate means what? To open our mouth. The activation function is a gate to speak out. So this is how the mathematical function of a activation function goes on. So I am talking about one activation function is sigmoid here. So sigmoid function ranges from 0 to 1. So 0.5 here, 0.5 is the threshold. Whenever the activation function reaches 0.5, it will trigger and the gate will open. Gate activated. Below 0.5, no, it will be at 0. That's why when a mosquito hit on our body, we will wait for some time unless it sucks the blood. We will wait for some time because our body also does not know that there is some object on our hand. For suppose hot object is also same thing. Whenever we touch a hot object, for some time it will be very good. If the heat is keep on increasing, then our brain will tell that remove hand, stimulate. So that is what the threshold of our brain. Till certain time only it can withstand. It can hold it can hold the skin and all. So later on it will tell that stimulate. The same way is happening with the algorithm also. Whenever you give any data set to it, it will analyze the input data. What are the features are there inside the image? What is exactly the input, whether it is a data set or an image? It will analyze it and then it will give it to the neuron. The neuron will do the multiplication of the inputs to the weights and later on it will give it to the activation function. The activation function will give the output of it, whether there is a diabetes or not, whether there is any heart disease or not. This will keep on go like this. Now, I hope the concept is very clear of neural network with the forward neural network and the activation function. Now, what happens if the error is more? How to reduce this error? Now, let us see the concept of backpropagation. Now, let me explain with you a small example of our day-to-day life, what a student do. What a student do, so that all academics and the industries and the researchers will engage with this example as it is a more close to us, because in our day-to-day life, we are the students. Every day we have to learn something. Neural network with backpropagation now. How to reduce the error? This is the only concept now. How to reduce the error? Backpropagation is a supervised learning algorithm commonly used for training artificial neural network, for minimizing the error between predicted output and the neural network and the actual targeted output. Whatever I want, if I am not getting that, if I am getting something else, then how to make it to the whatever I want? So that is what the actual to the predicted. Let me explain with the examples now. Let us consider a data set. Student features day-to-day life is X1. He will play for 2 hours daily. Daily he will play for 2 hours. The next feature of his, like habit, it's not features, nothing but habit. Let me tell. He study for 4 hours daily and he'll sleep for 8 hours. Okay. I thought if we maintain like this, if we play for 2 hours and if we study for 4 hours and if we sleep for 8 hours, I thought that he will pass. The student will pass in a semester exam, I thought. So this is my actual output. What I thought is, play for 2 hours, study for 4 hours and sleep for 8 hours. And the output is 1. This is the actual output. Now let us start our algorithm. Forward propagation, what happened now? The inputs x1, x2, x3. These are the inputs. The inputs will pass to the hidden neuron, right? There is a neuron. The input should pass here. And in these 2 steps, step 1 and step 2, right? So input will pass to the hidden neuron. Then 2 important operations will take place in this. First one, inputs are multiplying with the weights. So whatever x1, x2, x3 are there, it will multiply with the w1, w2, w3 and add it to the bias and the activation function keep on go. Here I am using activation function as sigmoid. So now let us see. Y hat is the predicted output. So what I thought actually y equal to 1, he will pass. What y hat I got? Failed. Now what to do then? There is a lot of error now. There is a lot of error. I thought he will pass, but he is failed. Now what to do? With the neural network and all. See, now the human nature will keep on move. How it will move, you see now. Y hat is the predicted output. Suppose y hat is the predicted as 0. But we know that we need to compare to check with y hat and the y almost. See, now the error is more. The loss is more. I thought he will pass, but he has failed. The error is more now. The difference can be found by loss function. You can see the loss function. Y minus y hat whole square, 1 minus 0 whole square, you got 1. The loss is more. Now how to reduce this loss? This loss can be reduced with the help of backpropagation. However, backpropagation is playing a crucial role. Now let me explain with you an example. For suppose, whatever the features I said here, he will play for 2 hours, study for 4 hours and sleep for 8 hours. I thought that he will pass. Now the student has failed. Now what is the alternate thing he has now to do? Pass for that subject. I hope backlog. He got a backlog now. Now what he will do? He will write the supplementary. So how he is reducing the error? He will reduce the error with the supplementary exam now. For that, what he do? He will change these all things now. He will change his entire schedule of the day. Now what he do? He will play for 1 hour. Now what he do? He will play for 1 hour. Play for 1 hour. Study for 7 to 8 hours. This is how to reduce the error. Previously he played for 2 hours. He studied for only 4 hours. Now he reduced the play time to 1 hour and increased the study to again 2 to 3 hours more. So now the backpropagation, whatever the previous semester's question papers are there, everything, he will collect it now. He will collect and he will sit and he will study, keep on studying. The same way the neural network is also doing the same thing. Whenever the input is given, instead of cat, if we say dog, whatever the brain say, sorry, I said some mistake, and it's a cat, you will recall all the features of that cat, how exactly the cat looks, and then you will tell that it's a cat. So I made a mistake, that's why you will say sorry. So this is how the reducing the error in the human. The same way in the deep learning also. Whatever the inputs I have given, x1, x2, x3, this will multiply with the weights and the output is predicted as 0. I need output as 1, but I received as 0. Now what I have to do? Now I have to do the backpropagation. Now I have to update the weights. Now I have to update the weights now. How to update the weights? See, it's a very good concept now. Updating the weights. I have 1 and the predicted is 0. So I have to do back propagation here. If you see, there are small arrow marks, the back propagation here. I am doing everywhere the back propagation. Everywhere I am going back. Again I am going to the input. Again I will come back. So how this back propagation is happening, let us see now. In back propagation, what happened? We will update the weights. First, suppose let us take this is the W4. Okay, let me take this W4. First, suppose the W4 weight previously it was like 1. Let us think example. Previously the W4 weight is 1. With the help of this weight, what happened? The guy has failed. The student has failed. So now what to do? We have to update the weights. How to update the weights? Now the W4 new will be W4 old minus learning rate. What is this learning rate? Realizing. That he has to realize in a very small way. The learning rate should not be more than 0.001, 0.001 only. It should not be like 0.7, 0.8 or 0.9 or 1. It should not be like this. The learning rate should not be high. If learning rate is high, the algorithm will not settle. If algorithm is not settling, the result will be vary. Continuously it will vary. So this is how the learning rate. Learning rate with derivative of loss with derivative of that weight. What is the loss we got? We got loss as 1. With respect to which weight? With respect to W4 weight, we got the loss. So, for suppose the W4 old is 1 minus learning rate is you are taking 0.001 and the loss is somewhere around something. So, if we do this calculation, definitely this 1, whatever the old weight is there, W4 equal to 1 is there, 100% it will reduce. At least with 0.999 or 0.98, somewhere it will reduce. Whenever the weights are keep on reducing, then again it will go back to the initial position and it will check for the result. Until unless he pass, he will keep on study now. So this is what happening with the back propagation in the algorithm also same. Whenever we give any image, for suppose brain tumor image we are giving, instead of brain tumor exactly where it is there, if it predicts wrong, the algorithm will keep on keep on check, keep on update the weights. Lot of iterations it will do. After completing all the iterations, then the result will be shown as a proper way where exactly the tumor is. So this is what the overall concept of neural network with back propagation. I hope you have enjoyed the session. So this is how the overall concept will be keep on goes. Whenever the weight of W4 is updated, next it will go to W3 and it will update this weight. Later on it will update the W2. Later on it will update the W1 weight. Once the weights have been updated from previous to the new weights, again it will go forward propagation. Again it will check. Instead of 0, now we should get 0.5. Again it will come back. There is an error of 0.5. Again it will come back. Again it will go. Again it will move to the error to 0.6, 0.7. The result will be keep on go until you get 1. These iterations will keep on happen. Backward, forward. Backward, forward. This will keep on happen until you realize that what mistakes you have done. So this is what the algorithm keep on do. So this is what the neural network with back propagation. And you can see here, here learning rate alpha should be minimum value 0.001. The small learning rate will help the researcher global minima to gradient descent, which possibility to the optimizer. After updating the W4 weight, the other weights like W1, W2 also will be updated respectively. And this is what the formula for updating the weight. W3 new equal to W3 old. Whatever the old weight is there, minus learning rate, minus derivative of loss with derivative of that respective weight, W3 or W4 or W. This is how the process will go. This process will happen until this should be, error should be 0. Error. The error should be 0. Until that the process will keep on go. Feed forward and feedback. What is the difference between feed forward and feedback? We can see feed forward neural network. Forward neural network, information flows in one direction. Okay. Architecture consists of input layer, one or more hidden layer and the output layer. That's it. Usage commonly for the classification and regression task. Now, the feedback neural network involves feedback connection where the output can be influenced the input. That's why whatever the output we got, if you need y equal to 1 but y hat equal to 0, this will influence the input. this will have a more influence on the input. Again, the input, the weights and everything will keep on changing and it will come forward. So architecture can have recurrent connections that allows information to circulate within the network. Recurrent connections mean more. Forward, backward, the recurrent connections will be more. Multi-layer perceptron can be used in biometric systems and identifying verification, biomedical, robotics, detecting anomalies, etc. etc. These all the algorithms will be used. So now, this is how the multi-layer perceptron looks. If you see, a multi-layer perceptron is a type of artificial neural network that consists of multiple layers of perceptron, also known as neurons or nodes. So there will be more hidden layers. This is the hidden layer 1 and this is the hidden layer 2. So there will be more hidden layers, multi-layer perceptron. So one or more hidden layers will have. MLPs are a classical of neural networks that have multiple layers, including input layer, one or more hidden layer, and then output layer. This is what the multi-layer perceptron looks. Here also, in the multi-layer perceptron, if there is any mistake, y hat equal to 0, then again it will go like this only. Same way it will keep on move, 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 it will keep on move. Again it will come forward. Same like our brain, how it is happening. If we do any mistake, we will recall it. Ayo, we have did this mistake, then we have to recorrect it. So this is what happening with the algorithm also, same thing in the neural networks. So whenever we give the data set, it will analyze and it will give you the output. So if we see chain rule reaction, how the chain rule reaction is happening. Suppose the inputs are x1, x2, x3 and x4, which are getting connected with the two hidden layers. In hidden layer, there are 3 neurons. In the hidden layer 2, there are 2 neurons. So in hidden layer 1, there are 3 neurons. In hidden 2, there are 2 neurons. So this is how the process of whole thing is happening. The best way to define the hidden layer is W11 and the first hidden layer, and the second hidden layer is W112. The second layer. So this is how the overall processing happens. So this is a chain rule, how each and every weight, if we are taking W3, how W3 is happening, how W311 is happening. See here, W311 is there, and here W211 is there, W111 is there. So how these all are keep on going backwards and how it is doing process and how we are getting the output. This is what exactly is shown. Let us dive into the another topic. I hope the chain rule reaction is understood. How exactly the weights are keep on updating, I have said. So this is all the theoretical part for that and the mathematical equations for that, how exactly the weights are keep on updating. So gradient descent. If we see the gradient descent, what is a gradient descent? It is an optimization function. It is an optimization function. To minimize the error, it will help because for updating the weights, to update the weights, optimization functions we use. See now, gradient descent is an optimization algorithm used to minimize the functional iteratively. This algorithm repeatedly adjusts the parameters of the model in small steps until it reaches the minimum or the point where the further adjustment does not significantly reduce the function value. The meaning is it should reach its maximum extent where there is no error, the algorithm is settled, and the output is whatever the actual output is there, the predicted output is also same. Until unless it reach, the weights will keep on update with the help of this optimization. Gradient descent works into update all the weights. It will help in update all the weights in such a way that the be able to y hat is similar to y. So the predicted output should be equal to the actual output. Till that time, this gradient descent will keep on move. What happens in gradient descent? Let me tell exactly. It's a very small concept. So here W4 new, whatever the new weight is there, we are doing with the old weight, right? This is already formula we have seen in the previous slide. So W4 old minus learning rate into the derivative of loss with the red expert of derivative of that weight. So now what happened in this? If you see the graph, this side is nothing but value of weights and this is nothing but the value of the loss. So now for suppose my initial weight has fallen somewhere here. This is the minimum point the algorithm should reach. The algorithm should reach. So this is the minimum point where the algorithm should reach. So what happened? The algorithm will start moving step by step iteratively. Iteration 1, iteration 2, iteration 3, iteration 4, iteration 5, etc. It will keep on move with the iterations now. So likewise, it will keep on move. So until unless it reaches the last iteration, thinks that the algorithm is settled and there is no more of movement is needed. So that time, this gradient descent will stop and the output will be displayed. So this is how the gradient descent works in the optimization techniques. It helps in the updating of all the weights. So there is another concept called stochastic gradient descent. We have to know that what is the difference between the gradient descent, stochastic gradient descent, mini batch stochastic gradient descent. So these are three concepts are there. These three concepts will work with a different kind of data quantity. So if we see gradient descent, it works with whole data set. It works with whole data set. The gradient descent will work with whole data set. It will apply the optimization technique on the whole data set. If we give 1000 samples, it will work on 1000. If we give 2000 samples, it will work on 2000 samples. But stochastic gradient descent, it works on one iteration or one epoch with one data. Only with one data it will work. The stochastic gradient descent, it will work with one iteration with one data. Mini batch stochastic gradient descent means it will form a batches like 20 or 30 or 10 or 5 or 40. Like this, it will form some group of batches and it will start operating on this. So based on the dataset quantity and all, these three optimization techniques will keep on play a major role in the algorithm. If we see now, stochastic gradient is a variant of the gradient descent optimization algorithm used in the machine learning and optimization. Unlike the traditional batch gradient descent, which computes the gradient of the entire training set to perform a parameter updates, stochastic gradient descent process only one training example at a time. It will not take like gradient descent all at a time. It will take, stochastic gradient descent will take one data, one time. So this is what the difference between the gradient descent and the stochastic gradient descent. I hope the concept is very clear, what gradient descent and stochastic gradient is doing. So now let us dive into the next topic. This is the difference between stochastic gradient descent and the gradient descent. So in gradient descent, the model parameters are updated based on the gradients of the entire training data set. It can be computationally expensive and especially for the large data set because it will take more complex time for that to execute the process. So at that time it is very difficult. Stochastic gradient descent what do? It will take a one data sample at one time and it will do. But mini batch is something different. It will form into a batches. For suppose there is 100 data set is there. It will form into batches like 10, 20 or 30. It will form into batches and it will give it to the algorithm. So this is overall the difference between the gradient descent, stochastic gradient descent and mini batch stochastic gradient descent. This is the difference between these all. I hope the concept of this gradient descent, stochastic gradient descent and these all concepts are very clear and all. So I hope you have understood the introduction to the deep learning, what exactly the deep learning is, what is neural network, from where from perceptron to the multi-layer perceptron we have moved. Initially the perceptron has facing a lot of problems. Based on that problems only we come up with the backpropagation. At the backpropagation we have come up and then to update the weights and all, we need the optimization techniques. Hyperparameter tuning, we need the optimization techniques. So from where these all optimization techniques have come, gradient descent, stochastic gradient descent and mini batch stochastic gradient descent and all. Apart from this optimization, there are n number of optimizations with the nature inspired and bio inspired. So that's a very great and wide topic. So I hope till here the concept is clear. The introduction to the deep learning. I hope you have enjoyed the lecture and thank you all and thank you for giving me this wonderful opportunity and I would like to thank bottom of my heart to Malla Reddy University for providing me this platform to give a lecture to the esteemed academics, researchers and the scientists like who are reaching me. Thank you so much for today's lecture.